Okay, this is forces at an angle, but this is harder stuff this time. It doesn't have an actual angle, or sorry, it doesn't have a picture associated with it. I've given you the two answers here. So if you want to try it, you can go ahead and see if you get 35 and 44. All I have to do is pause it and go nuts. First thing I'm going to do is I read through the question and then draw the picture. So it says a 20 kilogram wagon pulled along the level ground by rope inclined at 30 above the horizontal. Okay, well, so there's my horizontal. Here's my wagon. And there's my 30 degrees. Frictional force of 30 opposes it, so out of the bottom of this thing I'm going to go 30 newtons. How large is the pulling force of the wagon if pulled with a constant velocity A and with an acceleration of 0.4 b? So we want to find this pulling force. Okay, so that's what we're looking for. First thing I know is that it's being pulled horizontally, which means I'm only interested in dealing with Fx when I'm dealing with this 30, and I know that Fx is equal to F cosine of 30, which will come into play later on. So first one I'm going to do is with constant speed. Well, when something's got a constant speed, constant velocity, that means that your acceleration is equal to 0. Which means if you're not accelerating, that means that whatever opposing force 30 has got to be equal to whatever pulling force in the x direction, which means we know then that Fx has got to be equal to Ff. Well, that means then Fx is equal to 30 newtons. So we know that, but we don't want Fx, we want the pulling force. So we want F, not Fx. Well, I know that Fx is equal to F cosine 30, which means that 30 is Fx is equal to F cosine of 30. Solve this thing out for F, so I get 30 over the cos of 30, which means that my pulling force is 34.6 or 35 is what the answer is. There you go. B. Now we have an acceleration, which means that no longer is the acceleration 0. So you go F equals ma. This is F net. What are my two forces? Fx and 30. So Fx minus, I'll go Ff for now, is equal to ma. Fx I don't know yet. Ff I know is 30. My mass, do I know my mass? 20 kilogram wagon. And my acceleration is 0.4. So I solve this for Fx. Fx is going to be 20 times 0.4 plus 30. So do I want to do this right away? No, I think I'm going to swap this. I know that Fx is F cosine of 30. Oops. So let's come up here. F cosine of 30 now is equal to 20 times 0.4 plus 30. So I can solve for F. 20, 0.4 plus 30 divided by cosine of 30. Solve all that out and you get 43.9 newtons, which is 44 according to the answer. So what I did was I plugged in my F cosine of 30 for Fx here, which is off of this picture up here. You might not want to do that. You might want to find this as a number and then do exactly what we did way up here. Put your number instead of the 30, whatever number you get for this, put here, and then solve it same way as you did here. And you'll get the same 44 if you do it the same way. There's two different ways of doing it. Okay, so this is a little harder version, obviously. A lot more work involved. There you go.